Welcome to the third and the final part of this three-part tutorial Python project called cyberbullying detection. In the previous part, we will discussing the data pre-processing steps and the data transformation steps. As I've mentioned in the last video, we were creating the three attributes to feed our machine learning model, which were the density, the weighted average of the severity, and the sentimental analysis done through the weighted library. Here you can see we have created a copy of the data frame, and then a target M1 variable is defined, which includes the whether a tweet is considered offensive or not. Here, as you can see here, the tweet which I was showing you throughout the pre-processing steps. Here is it. You can see here the density is here, the severity is here, and the sentimental analysis is here. Here we have visualized the prediction data, which is the data which shows us whether a tweet is considered offensive or not. So here we have visualized it. Here we can see the densities range from 0.0 to 0. Almost to 0.4, and there's some with 0.5, 0.7. The reason why I haven't multiplied it with 100, because as you can see here, it is 0.214, which obviously will be multiplied with 100, which means that 21% of the whole sentence is filled or is tensed with offensive words. The reason why I haven't done it, because if there are big numbers, then the model can be skewed towards the big numbers, and it can produce inaccurate results due to it. So after visualizing it, we can convert it or split it into training and testing data. As you can see here is the training data. And here is the training data, and here's the testing data. Here is the training data and the respective class of it, and here's the testing data and the respective class of it. We have picked 80% of the data as training, and the rest 20% is set to as testing data. You can change the numbers from 80-20 to 75-15, 70-30 as your preference. It is completely up to you. The second one here is random state. It basically splits and shuffles the data. You can set this number anywhere from 0 to 100, even more. It is completely up to you. You can check, you can insert different numbers and check which one gives you better results, because the shuffle can change the numbers, the accuracy, the F1 score of the model. And this is a really crucial parameter set here, the stratify. This makes sure that the data comes out as balanced. We have put a target M1. It will know now that there are two classes, not cyberbullying and cyberbullying, and it will create balanced data set of it. I've told the benefit of balanced data set in the last part, that it is beneficial for us because a model will be biased towards a particular class if it has more distributions than the other class. Here you can see we have used SVC, logistic regression, random forest classifier, k-neighbor classifier, a naive bias, and extra tree classifier here. These are the results. You can obviously multiply them by 100, and this would become 83%, 83%. You can see here we have 84.5% result here with random forest classifier, with an F1 score being of 0.84% here. Obviously, through these results, we can see that a random forest classifier gives us the best results, and close logistic regression and SVC are close seconds, whereas KNN extra tree classifier gives us the worst results, with coming up at 74%. So we've seen here, as I've told you before, it gives us the best option, random forest classifier, so picked it as our model of choice. We have fitted the model with the training data and training target, so it can learn the data given to it, and we have dumped it in a file called cyberbullying detection.sav. So I've told the benefit of pickle in the first part is that we can dump the whole results. Look here, we have ran the whole code from here to here, right? This will take us about maybe 10, 15, 20 seconds to run all of this. We can skip all those 20 seconds by dumping the data in a pickle file. So we can just import it and use it right away rather than running the whole code, doing all the pre-processing steps again and again, the data transformation steps, and then we check the accuracy and F1 score, and then we pick the model. We can skip all of these steps by picking and by saving our results in a file and then importing the file later on. We can just use, we can comment all of that before, and we can just start the code from here. There is no problem with it. As you can see here, we use the model to predict our text, our single text which we were using before, and as you can see here, it comes out as 1, which means that the tweet is considered offensive or is considered as cyberbullying. So if it gives 1, you can go visit the Python file which is available at the GitHub page. You will see that the condition is that if it is 1, then the rest of the code continues. If it is 0, then it shows that the tweet is not offensive. You can implement this in a social media platform. If it comes out as 0, the user tweet is posted or user text is posted, and if it comes up as 1, it is stopped. Like it isn't posted. A warning is generated to the user saying that your tweet cannot be posted because it is considered offensive or it is deemed as offensive. So you should revise the tweet and change the words and make it less offensive. So here, if it is considered offensive, our next step is to determine the type of cyberbullying present, right? We had a second data set here, which helped us determine which type of cyberbullying is present, which type of offensive it is. It is related to religion, age, gender, race, or ethnicity. Obviously, this can be used to gain different insights about the text. We can perform different researches on it to determine the patterns of how a religion offensive tweet is constructed, how an age offensive tweet is constructed, how a gender offensive tweet is constructed. So we can definitely, will help us in future in research purposes. That is why we have considered to take a step to determine the type of it rather than just considering if whether it is considered offensive or not and just stopping at that point. So you can see here we have 4 different glossaries or lists here, which help us determine whether data is considered, which type of it is. Ethnicity and race, you can see here it belongs to ethnicities or races. Age here, different ages, like different terms which younger generation or kids in high school or element or in schools use. As you can see here, gender ones are used, which are obviously related to different genders. Religion, obviously different religions, Islam, Christianity, Hinduism, different religions are present there. To these glossaries, we can obviously, this is for the data set. This cell is present for the data set, whereas this cell is present for our text. As you can see here, we have run the results and it shows us that cyberbullying is present. We have seen that earlier. Ethnicity, race, there are 2 terms here. Gender has 1, religion is 0, and gender is 0. So we create another variable, a copy of our data frame. The reason why we create a copy rather than just using this, if I can show you this, can erase this, and we can use this. This will create a shallow copy, meaning if we make changes to prediction M1, M2, it will change the classified data as well. So we have to create a copy of it. So making changes to prediction data M2 doesn't change the classified data. We don't want it to change it, to change the data. So here we will store the type related to each row, and then here will be the in here we will we were classifying this. We were storing results of this data set, and in this we will be storing the result of our text here. In these results, as you can see here, I have tweet data m2. You can see here the results are here. We can obviously train and split the data set. Again, we are using the stratify, and you've seen here I've used a different random state 46. It wasn't 46 before. Again, you can iterate from 0 to 100 or even 120, 150, 200 and check which seed will prepare the best results for you for your own data set. Again, 20% is given to the testing data set. You can see here we have visualized our data set. You can see age glossary, the gender one, the religion one, and the ethnicity race. How are they visualized and how much quantity they are present. Again, the same models are used to predict. As you can see here, we have really good results here from all our models, but you can see here logistic regression. It gives us the best result, 96%. All right, so we have picked logistic regression to go through. You can also pick SVC. It gives us the right amount of, even though it gives us a better F1 score, it is completely up to you. You can see here, this gives us a better F1 score than any of the classifier. This gives us the same amount of accuracy. You can pick any one of it. You can use even more. There are more evaluation metrics like recall, precision, many more. You can pick as much evaluation metrics as you can. It is completely up to you. I picked a logistic regression, and again fitted the model here, dumped it here again, loaded it completely, so I don't have to run all of this, check all of these, create a training testing data, and then I should start from here, bring all these glossaries back, and then determining all of these numbers, and then splitting it into training testing data set. I don't have to, and then checking the models as well, the evaluation metrics. I don't have to do all of that. Just I have to import this, load this file, and then I could start running the code. So make it so it takes less time. As you can see here, the model is used to predict the text. As you can see here, it is from the original data set. If I can, as you can see here, I can go up here. This was the original tweet, and it has gone through all of these pre-processing steps, and it is considered that these three are the offensive words, the severity level is this, and the type it has determined ethnicity, and then we can clearly see that it is an ethnicity and race problem here. It isn't specific to any gender, any age, or any religion. It is targeting a specific kind of a race, and the severity is determined by 3.666, and these are the offensive words. And here we are closing the connection of it. You can do whatever you want. So in these steps, in these three parts, I have told you the whole process of creating a cyberbullying model. Obviously, this you can suggest improvements so I can implement them. You can obviously improve it by yourself. The code is available, the data is available, so you can use it and just continue from it rather than starting from scratch. So that is exactly why I've uploaded all of the data at the GitHub and not kept it to myself, so the community can use it. They don't have to start from scratch. They can pick up the work I've done and then continue from that on. So these have been this has been the last part, and the conclusion for our three-part project, Python project called Cyberbullying Detection. Thank you for watching.